Hi everyone. Hi everyone. In this class, we will look at two projects done by Calatrava, and we will study the underlying geometry, and we will try to create a parametric model in Dynamo. The first project is Canopy Structure, which looks like a tree. And the first thing that we can do is trying to identify the geometry that composes this shape, this structure. First of all, we can see that the trunk is done by one element, which looks like following an arc shape, and at the midpoint, almost near the midpoint, it forks and connects to the center of what we can call the crown of this canopy. The crown is a square-based shape with 8 diagonal beams, 4 ribs connecting the center of the crown to the corner, and 4 edge beams, which again are following an arc shape. The ribs are then connected to the edge arches by a set of secondary beams. Before jumping into Dynamo, we can try to write down a possible workflow and trying to identify all the steps that will be required. So, for example, we could start from defining 4 points: the origin, the center of the crown, 2 points at midspan, and 1 point at the corner. Because the geometry is symmetrical, once we have created the shape that belongs to a quarter of the canopy, we can use mirror or rotate nodes to generate the full extent of the geometry. In doing this, it will ideally simplify the script. So once we have identified these 4 points, we can draw a construction line from the center of the crown to the corner and use that to build the rib arc. We can then create the 2 diagonals, which are basically 2 lines connecting the midpoint of the outer arc to a point on the rib. So they are not connected to the origin of the crown, they are slightly moved away from it. And we can then start creating the 2 arches at the edges. We can then split the rib and create the secondary beams. And then we can create the columns and find a point where the columns are connected to the rib. And once we have a quarter of the geometry, which is represented by these elements, we can rotate them and mirror them to define the complete structure. The other important thing is how to identify the parameters that we will input in the script and we will use to dynamically adjust the shape. I think the minimum amount of parameters is 8, and they are listed in this image. So the crown width and length, which assuming that the shape is a square, they will be the same. The origin and the height of the column at this point. The height of this point of the crown at mid span and at the corner. So the mid span point is going to be higher than the origin point, and the point in the corner will be halfway through the midspan and the origin. You can then need to identify where the primary beams are connected to the ribs. We need to identify the rib rise and where the fork occurs, and then we can define the number of secondary beams. So if we go into Dynamo, we can first of all save the project so that Dynamo keeps saving backups in background. Otherwise, if it crashes, we will lose everything. And then let's start listing all the inputs required for this script. So half crown width is an integer. So if we go to core input, we can take integer slider. We can say that the minimum is 5 meters, maximum is 15, and let's start with a value of 6. And let's maybe group the node and give it a meaningful name. Then the crown height at the corner, again, we can say it's an integer. And it goes from, yeah, we can keep the same extreme and then just use 12. The crown height and midspan, we can take a number, and we can say the minimum is 0.3 meters, the maximum is 1.5, and let's set this number to 1. And this value is 12 meter plus 1, represents 12 meter plus 1. Then the center of the crown, that should be a point. So we can either go into geometry, point, and use point by coordinates, or we can double click and use a code block, which is bigger. So if we write point dot by coordinates, we can set that the x and y values to be 0, 0, to be in the origin, and then we need to define the column height, and this can be an input, and again it can be a value that we subtract from the 12 meters height at the corner. So we should copy the number slider, and we can then use the minus operator and say that we want to take 12 meters minus this should be from 0.3 to 1, and let's make this one 0.7. So basically this value will be 11.3 meters. And again, let's add these nodes into the group, and let's call it center of crown column. Then we need to define a primary beam, this point. So this is a point along a line. So again, it's a number, and it can go only from 0 to 1. Let's set the value to 0.1, and this is the primary beam to rib point. Then the arc rise, we can again set it 0.6. Number of secondary beams, these we can use an integer for that. And let's make it 7. The trunk fork position should be a number. Again, goes from 0 to 1, and let's keep it 0.6. Okay, so these are all the inputs that we need. And we can then start. So in order to define the 3 points required, instead of defining them one by one, we can create a rectangle and then extract the vertices of this rectangle. So if you go into geometry, there is a rectangle by width and length. So the width and the length will be equal to the half crown width. And if you look at the rectangle, we see that the way Dynamo creates this rectangle is by using its center. It will be more useful for us if we can define a rectangle by its corner, so we can then extract this point directly instead of having to find the midpoints on the curves. So the way we can do this is basically taking the other node that creates a rectangle by a coordinate system and a width and a length, and then define this coordinate system to be based on the center of the crown, but also translated by half of the crown width and half of the crown length. So one of the corner of the rectangle will be matching the origin of our crown. So if we use the translate coordinate system and we take to half crown width divided by 2, in X and Y, maybe it's difficult to see, so let's set the Z this point. So now this rectangle has a corner in the origin and we want to move it at the crown origin. So this is how it looks like. We can then extract these 2 points and the corner. We can hide the coordinate system in the middle. So in order to extract a point from a line, from a curve, we can use curve point at parameter. And when we feed the rectangle, first of all, we need to understand what is the starting point. So starting point and the end point, so 0 and 1 will be there. So the first point that we need to extract is the point at 0, parameters equal to 0. And then we have 4 points. So each point will be at 0.25 parameter. So 0, 0.25, and 0.5. And these are our 3 points. The advantage of defining them from a rectangle is that if you change the width of the rectangle, the points move accordingly. While if we had them defined by x, y, z coordinates, this would not be the case. So the next step is to extract the corner point, which is at index 1 from this list. And we can do it using a code block. And this is exactly the same as doing get item at index, where this is the name of the list of points that we're fitting it, and this is the index in square bracket. If we want to extract the other 2 points, we can either create a list, so corner point 0, comma, corner point 1, sorry, 0 and 2, okay. Or the same operation can be done with one node called deconstruct. So list deconstruct gives you the first point and then the rest of the points. We can then move these points to the correct set value. To do that, we can simply use the geometry translate and x, y, and z. So the corner should be at 12 meters. So we could, instead of, let's use the origin, let's set the rectangle to 12 meters height, so the first point is already in the correct position. The other 2 points, we need to move them up by 1 meter. And this is the Z translation. Okay, so the deconstruct list doesn't work because we need to take this point. So let's go back to the code block and do corner point, which is at index 1. And that's the point. And then let's create a list, corner point 0, corner, well, it's not corner point anymore, it's midpoint 0, midpoint 2. And then we can take these points and move them up to the correct location. Now, this is quite a long set of nodes to do a simple task. So what we could do is to create a custom node out of it. So if we select all the nodes and we right click and click on custom nodes, you can say rectangle dot by corner, and we can choose geometry as category. Geometry dot rectangle. And well, it's much better now, but still it's not very clear what's going on. So if we right click and do edit custom node, we see that Dynamo has already created some inputs and give that a name for us. So we have this Z translation is the height at corner, because these were 12 meters. Instead, this Z translation is the height at midpoint, mid arc, and the output of midpoint is the arc middle points, while this output is the corner points. So if we save the definition, and it will prompt to open the folder where all the definitions for your Dynamo version are saved. And if you are sharing the script with someone else you have on a different computer, you will need to include this Dynamo custom node definition with it. Okay, so we have now a better understanding of what's going on. So we can then start building our geometry. First of all, we can create the construction line. So line by start and end point, and this will connect the center of the crown to the corner point. We can then build the arc based on this line. So the arc will, which is the rib, will be an arc by 3 points. So the first point is the center of the column, or top of the column, center of the crown. The second point is a point along this line. We can say pointed curve, pointed curve, pointed parameter, and we can set it to be midpoint, for example. And this point has to run. The point is on the line, and we want to move this point up by the rib arc rise. So we can choose, we go again into geometry. I think that is geometry. We have translate. So we can take this point and translate vertically by this value. And the third point will be the corner point. And this is the rib. So let's group it. There is a color convention for Dynamo. I think the inputs are blue. So let's change them to correct color. And then we can just pick another color for the other one. Important thing is just give a meaningful name. Rib arc. We can then build the other two arcs, and they are different from the one that we just created, because you have to remember that we will mirror this arc along this plane from the YZ plane. So when we are mirroring it on this side, we want the point here to be, the arc at this point to be tangent to the arc at the other point on the other side. And if we use this shape, you already see that if you mirror this shape, taking a plane which is perpendicular to the line at one end, you will have a knot, a cuspid. So there is another way of creating an arc, which is by start point, end point, and start tangent. So the start point will be the middle point, the end point will be the corner point, and the start tangent, in this case, which we are mirroring, taking a plane, the YZ plane, the tangent would be a vector in x direction and the opposite for this point. So this point, well, is this point, so we need a y axis or y vector, which is vector of y and then vector dot x, and we need to, because we are feeding it 2 points, we need to feed 2 vectors. So the way to do is to create a list with these 2 vectors, and in this way we have our points, our arcs, and you can see the tangent to the arc at this point is 0. The next step is to create the 2 diagonals. So we need to connect this point, let's go back, this point to a point somewhere along the rib, and we choose that this point along the rib would be 0.1 from this start. Let's group them and call them crown edge arcs and change it to same color. So let's first, we can hide this curve, we can hide this point, and we can copy curve pointer parameter by choosing the arc, the rib, choosing the primary beam to rib point, and we turn on the preview. This is where it goes. So now we can again do line by start and end point, and say that this is the start point and the end points are again these 2 points. Okay, so if we change this slider, they will change. And hide this part. So these are the diagonals, primary beams. And so the next step is to divide the rib and the edges by our number of secondary beams. So before dividing the rib, we will need to split it, because we just want to divide this side of the arc. We are not interested in this side. So we can use a command called split. So if we go in curve, is split by points. This is the curve, and this is the point that I want to split. Now we can use deconstruct to select just the curve. Let's find 5. So if see that this is the curve that we want to divide, and we can again use curve pointed parameter, where our curve is rest. Let's check 5.0, that's the start, and we want to divide the curve in 7 parts, 7, which basically means in 6 points. So the way, and we want to discard the first and the last point because we don't need them to, we don't need these points because they already been, there's already a line connecting them. So the number of division is our inputs, number of call it secondary beam, so number secondary beams, and it's 7. And then what we want to do is to start from let's call it something short. Don't want to start from 0, so we start from the first one. We go to the one before the last one, and then this is the number of so yeah, to the proper input, the right input, you will get a list of 7 points, and here you just have one. The reason is simple, is the lacing. So when the lacing is set to shortest, what Dynamo does, it matches the shortest list length to the longest. So because we only have one curve, Dynamo just takes the first point parameter. So if we right click and change the lacing to longest, what Dynamo will do is they will take the first the curve and propagate the extent to all the points on the list. Okay, and we need to do the same for the edge arcs, and there, so we can take curve pointed parameter. These are the curves, and now let's look at what's happened. So because the lacing is longest, Dynamo takes the first element and the first element in the second list, the second element with the second element, and then it uses it applies all the other items in the second list to the second item. So in order to get all the points on this curve and all the points on the other curve, we need to have a cross product. And what cross product does is all the possible combination between the items in the two lists. We can then, there's another way, which is instead of using the lacing, you can use the levels. So if you run something like this, you will get the same result, apart from the fact that you see the rank of the list, or the nested list has been it creates a new nested list compared from when we use the lacing. So that's why I think the lacing, if you can use the lacing, I think it's easier and it's more simple to understand than the list at level methods. But it's up to you. Once we have the points, we can just connect them by two lines. And again, because because we are trying to connect 14 points to 7 points, we get this strange and wrong result. So what we need to do is we need to tell Dynamo, and the only way you can do this in this case it's with levels. You cannot do it with the lacing. Okay, is to tell Dynamo that we want to apply or to use this list for both. And these are the secondary beams. Okay, we can then create the column. So the column is going to be again an arc, and we can use the arc by start and tangent. So the start point, let's assume, is the origin. So we don't have that, but we can just get the origin from our node. The endpoint will be the arc middle point, and in the start tangent in this case will be a vector z. Okay, and then again we can do curve point add parameter. So these are the columns. The parameter is down there, and we can do a line by start and end point. Start and the end point is the center of the ground. Okay, so we have now built 1/4 of the structure, and we can now generate the rest of the structure by rotating and mirroring this geometry. So let's call this one forks. So the command to rotate geometry is again in geometry and then rotate. We can rotate from origin and axis. So the origin is the origin point. The geometry is a list of geometry that we want to rotate. So we need to create a list, and we go in order. We got the rib, the diagonals, the secondary beams, and the edge arches. The axis of rotation is the vector z. So if you think about the right hand, we want to take these elements and we want to rotate them by 90 degrees, 180 and 270. So let's start with 90 degrees. Again, what's going on? First of all, we are supplying a list with different ranks or with different depth. So in this case, because we are not worried about keeping the structure of this, keeping the arc, the ribs separate from the secondary beams, we can just flatten this list, have it in a more neat shape or configuration, and then we can just change the laser to longest. Okay, if we are adding another angle, then this one doesn't work anymore, and what we'll need to do is to use levels, and again say that we want to use the items at this position to repeat. Yeah, sorry, this position load. And then the last one is 270. Of course, we could have done 90, 270, and I want 3 bar. Okay. The last part that we need to create are the other 2 columns. I have not included them into the rotation because it would have create 2 columns in the same position. So instead of rotating them, we can just mirror them, and we need to mirror them taking the plane, the diagonal plane. So we don't have this plane, but we can create a plane that's basically perpendicular to it, and then we can rotate the plane and mirror it. So if we want to create a plane, there are different ways, and the one that we can be useful for us is, and the easiest one, is a plane by 3 points. So we want the origin to be top of the column, and we want the axis point to be the corner, and the third point will be the origin. So we have this plane. We can then use the same geometry, rotate, so the plane is the geometry, the origin is the origin, the axis again is the Z axis, and the degrees is 90. Okay, so now we have a plane, and we can use this plane to mirror the, move it over there, arc and the forks, and this is the geometry. Okay, now if we can play a little bit with the inputs. So, for example, we can change the value of this point, so we can make it rise it up or lower it down. We can change points where the primary beam are connected to the ribs. We can change the number of the secondary beams. Change the height. Width. And this is it.